In this video, we are going to trace a request all the way through FastAPI, from the moment it arrives at your server to the moment the response leaves. Understanding this order is not just trivia, it is the mental model that makes debugging middleware, dependencies, and error handlers feel obvious instead of mysterious. Here is the frustration. FastAPI does a lot of work automatically, and that is great until something misbehaves. You add a middleware that sets a header, but your root never sees it. You raise an exception deep in a dependency, and you are not sure which error handler catches it. Without a clear picture of the lifecycle, you are guessing. With it, you know exactly where to look. Picture an airport. You cannot just walk onto a plane, you pass through check-in, security, and a gate agent in that fixed order. Each layer can turn you around or add a stamp to your boarding pass. When you leave, the layers run in reverse. FastAPI's lifecycle is that same idea, a defined series of layers that every request passes through on the way in and every response passes through on the way out. FastAPI's lifecycle has 4 clearly named stages. Middleware is registered on the app and wraps everything. It sees the raw request before any routing happens, and it sees the finished response before it is sent. Inside that wrapper, FastAPI resolves your dependencies in the order they are declared. Then your handler function runs. Finally, FastAPI takes whatever your handler returned and serializes it into a proper HTTP response. Let us walk through this top to bottom. The @app.middleware decorator registers the timing middleware. When a request arrives, FastAPI calls timing_middleware first, before any routing. Inside it, await call_next sends the request through all remaining stages and pauses here until a response comes back. Next, require_token is a dependency. FastAPI calls it before read_item, checks for the header, and either raises a 401 or returns the token string. Then read_item runs, receiving the resolved token as a plain argument. Finally, FastAPI takes the return dictionary, validates it against the item model, and serializes it to JSON. Control returns to the middleware, which stamps the elapsed time onto the response header before sending it to the client. A few details worth knowing. Middleware is a stack, so if you register A then B, the order is A wraps B wraps your root, B runs closer to your handler. Dependencies form a tree, and FastAPI caches a dependencies result within a single request, so 2 roots that share a dependency do not call it twice. If a dependency raises an HTTP exception, FastAPI jumps straight to your exception handlers, and your handler never runs. And response_model is not cosmetic. FastAPI runs Pydantic validation on your return value, which means you get a clean error if your handler accidentally returns unexpected data. Knowing the lifecycle also tells you where to put your code. Middleware is the right place for things that apply universally, timing every request, attaching CORS headers, or streaming request bodies for logging. If you put business logic there, you lose access to FastAPI's routing context and it becomes hard to test. Dependencies are the right place for per-root concerns like auth or database sessions, especially because you can use yield to run cleanup code after the handler finishes. If you need to inspect the response after the handler runs, only middleware can do that, dependencies cannot. To summarize, every FastAPI request follows a fixed path. Middleware runs first and last, wrapping all other stages. Dependencies resolve immediately before your handler and can short-circuit the whole chain by raising an exception. Your handler runs, FastAPI serializes the result, and control unwinds back through middleware. Once this order is in your head, debugging becomes a process of elimination rather than guesswork.